Hello, welcome to GTech Techno Solution Private Limited. We are going to discuss about whole numbers and the properties of whole numbers. These are the topics that we are going to cover in this session. We will be discussing the definition for whole numbers, followed by which we will be discussing the predecessor. We will be seeing the properties of whole numbers, which includes the closure property, commutative property, additive identity, multiplicative identity, followed by associative property and distributive property. First, what is meant by the whole number? The numbers which are used for counting is known as whole number. So you generally count starting from 0. So 0 is the smallest whole number. There is no largest whole number. It goes on until infinity. What is a predecessor? The previous number in a counting series is said to be the predecessor. If you see over here, your 0 is the predecessor to 1 and 1 will be the predecessor for 2. So the one which is following a number in a counting series is said to be the successor. In successor, we have an example over here. 2 will be the successor for 1 as 2 comes after 1. And 1 will be the successor for 0 as 1 comes after 0. The predecessor and successor of a number is obtained by subtracting and adding 1 respectively. To get the predecessor, we have to subtract 1. To get the predecessor of 1, we have to subtract 1. So 1 minus 1 will give you 0, which is the predecessor of 1. And next we have 1. The next term, to obtain 2, we have to add 1 to 2 to get 2. That is 1 is your number. Plus 1 will give you the value as 2, which is the successor. Moving on, we have the closure property. In closure property, it is closed under the condition for addition and multiplication. It is not closed in the case of subtraction and division. So if you see over here, in closure property, for any numbers x and y will be a real number on the operation x plus y if x and y are real numbers. In very simple terms, if you multiply two real numbers, the resultant will be a real number. And if you add two real numbers, then your resultant will be a real number. It cannot be any other number. So this property applies in addition, but whereas in your division, dividing two real numbers may give you an irrational number, which is not a real number. So, the closure property does not hold in case of subtraction and division. Next we have the commutative property. Sum of two whole numbers is the same regardless of the order of addition. So if you see over here, we have to add 3 plus 8, which is equal to 11. And you will get the same answer as 11 even if you add 8 plus 3. So this is what is meant by commutative property. In spite the difference in the order of addition, you get the same result. Similarly, the product of two numbers is same regardless of the order of multiplication. 5 into 2 is equal to 10. 2 into 5 will be 10 as well. So, the position of your number doesn't matter in case of addition and multiplication. Next we are going to see an interesting example. Check this out. You have two variables, a is equal to 2 and b is equal to 3. 2 plus 3 will give you 5. And even if you add 3 plus 2, interchanging the position of the digits, you get the answer to be 5. Similarly, you have two values, a is equal to 2 and b is equal to 5. Adding 2 plus 5 will give you 7. Even if you add 5 plus 2, you get your answer to be 7. So the position of the number doesn't matter in case of addition. So this is known as your property. Next we have the additive identity. Additive identity is the one in which a number added to a given number does not change the number. So if you see, that is what is meant by identity. For addition, if you add 0, then the number will remain the same. This is known as additive identity. So adding your additive identity to a number, the number remains unchanged. Let us discuss an example to make things clear. 1 is your number, to which if we add 0, you get the same result as 1. So 0 is the additive identity of addition, because adding 0 doesn't change the number. So that is what is illustrated over here as well. We have a next example over here, in which we have the value of a to be 8, on adding which additive identity you get the value of the result as 8 itself. So adding 0 to the value of a, you get a itself. So 8 plus 0 is equal to 8. So 0 is the additive identity. In our next example, if you see, a has a value as 10. Adding 0 to 10 will give you the answer to be 10 itself. So this is known as additive identity, where 0 is your additive identity. Our next property is multiplicative identity. In case of multiplication, the multiplicative identity is 1. That is, to a whole number, if you multiply by 1, then the number remains unchanged. That is, you get the same number. That is what is meant by identity. So if you see, let us illustrate this with an example. We have a number to be 6, to which I am multiplying 1. So this gives your resultant to be 6 itself. So 1 is the multiplicative identity of 6, which gives the number itself. Next we have the number 9, to which I am multiplying the digit 1. So that gives my answer to be 9 itself. So 1 is the multiplicative identity of 9. Our next example illustrates the multiplicative identity case. If you see, we have the variable a with the value 3. So 3 multiplied by 1 will give you 3 itself. So 1 is the multiplicative identity of a. Similarly, a has a value of 10 in our example 2. Multiplying 1 with 10, you get the 10 itself. So the multiplicative identity of 10 is 1. Moving on, we have the associative property. In associative property, while adding the whole numbers, a number can be grouped in any order. 1 plus 2 plus 3 is nothing but 6. Your result is 6 on adding 1, 2 and 3. In associative property, your numbers can be grouped in any order. So now, if we change the order in which we add 1 plus 3 plus 2 is 4 plus 2, which is 6. So we get the same answer in spite of changing the order in which we add. So similarly, even if we add 3 plus 2 plus 1, that is a different order of 1, 2, 3, we get the result to be the same, which is 6. The similar property is applied in case of multiplication. 1 multiplied by 2 multiplied by 3, you get 6. Whereas, if you see, if you change the order, 1 multiplied by 3 multiplied by 2, you get the same value as your result, 6. So the numbers can be grouped in any order in case of multiplication as well. So 3 multiplied by 2 multiplied by 1, you get the value to be 6 again. So this illustrates that your associative property is by which you can group the numbers in any order to get the same answer in addition and multiplication. Next we have an interesting example to illustrate the associative property. You have the values of A to be 2, B to be 3 and C to be 4. So adding the three numbers, that is 2 plus 3 plus 4, is nothing but 5 plus 4, which is equal to 9. And even if I change the order as 2 plus 3 plus 4, 3 plus 4 is nothing but 7. So adding 2 to 7 you get 9. So we can notice that both the answers are same in spite of changing the order of the numbers. In our example 2, we have the value of A to be 2, B to be 5 and C to be 3. So when you add the numbers in a sequence 2 plus 5 plus 3, 2 plus 5 is equal to 7 plus 3, which gives your answer to be 10. And now I am changing the order. Say 2 plus 5 plus 3 is summed up first. So 5 plus 3 is equal to 8 plus 2 gives you the answer as 10. So if you notice over here, we have the answers to be the same in spite of changing the order of the number. So this is what is meant by your associative property. Next we have the distributive property. In distributive property, the product of a whole number with the sum of the other two whole numbers is equal to the sum of the products of the whole number with the other two whole numbers. To make this simple, we'll say that the product of a whole number with the sum of other two numbers is equal to the sum of the products of the whole numbers with the other two whole numbers. Let us make this statement even more clear with the example that is given over here. A has the value as 2, B has the value to be 3, C has the value to be 4. So we are going to calculate the value of 2 multiplied by 3 plus 4. 3 plus 4 is equal to 7. Multiplied by 2, you get your final answer to be 14. In distributive property, you will be multiplying this number inside. So 2 multiplied by 3 plus 2 multiplied by 4 will give you 6 plus 8, which gives your final answer to be 14. So if you see, both the values are same. Here we have our next example. Our A has the value to be 2. B has the value to be 15. C has the value to be 3. B has the value to be 5. So when we apply the property over here, 2 multiplied by 5 plus 3 is nothing but 5 plus 3 is equal to 8. Multiplied by 2, you get the value to be 16. 2 multiplied by 5. So that is how we apply the distributive property. We'll distribute the value of 2 to both the terms inside the bracket, which is an addition. So 2 multiplied by 5 plus 2 multiplied by 3 will give you 2 5s are 10 plus 2 3s are 6, which gives you the final answer to be 16. So if you see, both the answers are same. This implies that your distributive property holds. That is, the product of two whole numbers, where the second number is the sum of two whole numbers, will be equal to the product of the number and the product of the number with the second number which is summed. That is, the product of the number with the sum of two numbers will be same as that of the sum of the product of two numbers. Thank you so much for joining GTech. Hope you would have got a very clear idea about the whole numbers and the properties of whole numbers.